So far we've gone over 3 different ways to solve quadratic equations. Our ax squared plus bx plus c equals 0. So we've gone over 3 ways. One of them was factoring. That's the first way we learned how to solve quadratics. The second way was graphing, because if we graph it, we're looking for the x-intercept where it crosses the x-axis. And the third way that we went over was our square root method. The square root method was the third way that we went over. Now today we're going over a different way, the fourth method. Now the fourth method that we have is something called the square root method. All right, I have these in here. It's going to be something called completing the square. Completing the square is the fourth way that we're going to go about solving these quadratics. Now before we delve too far into this, I want to solve these here. We're going to do 2 solving by the square root method, because these here have special values that we want to look at. Once we finish looking at this here, then we're going to look at the square root method, or completing the square. These that we're going to do, these first 2 problems that we're going to look at and solve, are going to be solvable by the square root method. And the reason they're solvable by the square root method is because there is no middle term. There's no term with x. Now, our square root method said, as long as there's no term with x, we get x squared, or the term that's squared by itself first. So the first thing we would do here would be what? We would subtract 4 from both sides, because again, the square root method says I can get x squared, or the term that's squared by itself. Then we can square root it, and we would get our answer. Well, here when I subtract 4 from both sides, these cancel, and I get that x squared is equal to -4, yes? Then what do we need to do? We need to take the square root of both sides, and the square root of x squared would be x is equal to plus or minus, because again, anytime we square root both sides, we have to include the plus or minus. Now, what's the square root of -4? To what? 2i. Because it's negative inside of a radical, whenever there's a negative inside the radical, it comes out as I. And that leaves us with the square root of 4, which is 2. Now, up to this point, up till really last Thursday and Friday when we went over these complex terms, we didn't have the ability to solve it, because graphing would not solve this here. Because what we would get is a graph kind of like this here. It'd be above the x-axis. There are no intercepts. We would not be able to factor it completely without kind of knowing what the solution is. But this is it here. So the solution for this here, x squared plus 4, the value of x that makes this is 0, is plus or minus 2i. Those are the values for this here. Questions on this here? So from here on out, it is possible to get solutions with I, with these complex numbers. So we're going to solve one more. We're going to solve this here. 2x squared minus 11 equals -47. Now this one here, again, it doesn't have a middle term. We don't have a term with just x. And because of that, we can use the square root method. In the square root method, we get everything on the same, so all the numbers that aren't x squared, we get x squared by itself. So the first thing we need to do in getting x squared by itself would be to what? We need to add 11 to both sides. And when I add 11 to both sides, well, -11 plus 11 cancels, giving me 2x squared. Well, -47 plus 11 is going to be -36. So we get 2x squared equals -36. And then what are we going to do next? We divide by 2. And when I divide both sides by 2, I get that x squared equals Negative 18. X squared equals negative 18. So is x squared by itself? Yes, and since x squared is by itself, we can take the square root of both sides. And the square root and the square for x are going to simplify, leaving us with x is equal to plus or minus. Now, the square root of negative 18, well, I know the negative is going to come out as I. It's going to come out as I every single time. Now, for 18, square root of 18, we can plug this into the TI-30XS, the calculators over there, and it'll simplify it for us. And they will tell us that it's 3 square root of 2, because 18 is 2 times 9. And I picked that because 9 is a perfect square. The square root of 9 would be 3, which leaves us with 2 left over. Or we can pull the I term out and just take the square root of 18 in that TI-30XS, and it'll do it also. Questions on this here? Any questions on anything we've done so far today? We good with this here? Now, finding the zeros would be the exact same thing we just did. Finding the zeros, finding the solutions, finding the x-intercepts. Those are all the same way to say the same thing. Finding what value of x is going to make this function equal 0. That's our main goal with all of this. Now, with completing the square, what we're going to be looking at here, what this is encompassing, is kind of based off of the square root method. Now, there's one problem I definitely did skip, that x squared minus 16x plus 64 equals 100. We're not doing that. I go back and forth with that, because it will work by completing the square. It's just, it ends up going in a circle a little bit, but I'm not going to worry about it. What completing the square does is it works with the square root method. Because if I could take, so it has squared plus 16x plus 64 is the equation we have on there, yes? Minus 16x, thank you. This here. If I were to factor this, we'd have 3 spaces and 3 spaces. Since the constant term is positive and the middle term is negative, the signs would both be negative, yes? What are the factors of x squared? It would be x and x. And the factors of 64 that would work for this would be 8 and 8. When I multiply something by itself, it's the same as squaring it, yes? So this here, this 3-term polynomial, this trinomial, can be written as a set of parentheses squared, yes? Well, heck, at this point, if I took the square root, those would simplify, wouldn't they? So almost, if I'm able to write any polynomial, these 3 terms, as a set of parentheses squared, we could use the square root method on anything, couldn't we? Yes. And that's where the key lies in this completing the square. That's what they're talking about. They're talking about a way, 15x, to find a value of c so that I could write a perfect square, so that I could write any polynomial as a set of parentheses squared, no matter what it is. That's the key to completing the square. That's what makes it essential, and it also makes it one of the 2 ways that works every single time. There is not a quadratic equation that we cannot solve with completing the square. This is one of the first ways that will work every single time. This is one of the 2 ways that will work every single time. You're going to like the other way better. But this here has some basic steps to it. Now, the first step that's really important is finding the value of c. Because there's a method that I could find the value of c that will make this a perfect square trinomial, that I could write it into a set of parentheses squared. Now, the first thing we have is that for any trinomial, to get it to be a perfect square trinomial, to find the value of c, we're going to take it, c is going to be this b over 2 squared. Because when we plug in the value of b into this, it will give us a value of c that will make this trinomial into a form that we can rewrite as a set of parentheses squared. Well, again, we're looking at ax squared plus bx plus c. So looking at this here, what is the value of b and its sign? So where is b? B is in front of the term with x to the first, or just x, yes? What's the number that goes in front of x? 14, so the value of b is? So to find c, I'm going to plug in 14 for b. Now, because it is positive plus 14, that means the value of b is to be plus 14, it's going to be positive 14. So if there's a minus in front of it, if it's minus 14x, the value of b is negative 14. It takes the sign with it. Now, what is 14 divided by 2? And 7 squared is 49. So the value of c for this polynomial is, so our perfect square trinomial is x squared plus 14x plus 49. That's our perfect square trinomial. Any questions on this here?
Is that the answer, or is that
Half of it. So find the value of c that makes it a perfect square trinomial. We did the first part. We found the value of c, we plugged it in. Now, so looking at this here, I did the factorization for this on the sideboard. Now, we had x plus 7 squared. So we know it's going to have to be x for this here. This has to include x something squared, yes? But looking at the work we did, was there a positive 7 that shows up anywhere that we solved or did anything with? Well, yeah. Awesome. Right in here before we squared it, didn't it? Before we squared it, we did have the positive 7, which kind of matches up with when we factored it, we found it to be x plus 7 squared. And that seems like it might be a coincidence. It's actually not. Whatever the number is before we square it is going to go in here with x.
so you're just doing it and then I'm doing it?
Mm-hmm. Because to get our constant term, this 49, we're taking this c value and essentially multiplying it by itself. What's really nice is, say this had been negative 7. So it was minus 14x, we would get negative 7. What do you think is going to go inside there? It'd be x minus 7. It takes the sign with it. So if it's positive or negative, whatever's inside these parentheses before we square it will be the number that goes right there. And it'll work out that way every single time. Now, if you're wondering, do we really need to square it? When we start solving it, that's going to be important. When we start solving it, we need that. Because really, I'm taking this equation and adding 49 to it, yes? Well, if I do something to one side, I have to do it to the other. I can't change the equation, so we need to know what that number is. Any questions on any of this so far? Your assignment for tonight is going to be only dealing with this c, finding c. There's 9 problems. You're finding c, kind of plugging it back in, and then the set of parentheses squared. We're going to do these here, these 3. I'm going to show you how to do completing the square from start to finish for 2 problems, and then we'll delve more into it tomorrow. So, you have a little bit more space than I do because I'm going to be erasing things. X squared plus 8x plus c. The value of c is b over 2 squared. So for this first one here, what's the value of b? A divided by 2 is 4. And 4 squared is 16, yes? So if I plug it in, we have x squared plus 8x plus 16. Any questions on anything we've done so far? Any questions on how we found the value of c? Well, now we need to rewrite it as a set of parentheses squared. So what would go in with the x? Plus 4. Because we get it from what's inside those parentheses before we square it. And that's your answer. And if you're wondering, yes, I will have a few of these on the test, where all you got to do is find the value of c, plug it back in, and then simplify it to a set of parentheses squared. Questions on this here? Let's look at the next one. So again, c is equal to b over 2 squared. So for this one here, x squared minus 2x plus c, the value of b is negative 2. It wouldn't be positive, it's going to be negative 2, because it takes the sign with it. Now, negative 2 divided by 2 is negative 1, which becomes positive 1. So we have x squared minus 2x plus 1. Now, what's going to go inside the parentheses? So we would have x minus 1 squared. Any questions on any of this here so far? We feel comfortable with this here? Let's look at the last one, because I have a feeling y'all are going to feel a little uncomfortable with this one. C is equal to b over 2 squared. Now, what's the value of b? What's negative 9 divided by 2? 4.5. That's not a nice number, is it? No. We like whole numbers. So if I want to, I can actually leave it as negative 9/2. I can leave it as this fraction. There's nothing wrong with that. Because if I square it, it would just be 81 over 4. Or approximately, or not approximately, it would be 20.25 as a decimal if it was squared. Not squared, it'd be negative 4.5. They're the same deal. Any questions on this here? Most likely, I think the big ideas math is going to want this as a fraction. So I would put it as a fraction. Because really at this point, we're just saying x squared minus 9x plus 81 over 4. Because we just added it to it. That's the value of c. Yes? Now, we probably have a feeling, you have a feeling doing this part's probably going to be a little bit more difficult. Well, what's inside the parentheses? Negative 9/2. You plug it in like that. Now, when it comes to the test, if you put it as a fraction, that's fine. If you put it as a decimal, that's fine. Because as a decimal, this would have been x squared minus 9x plus 20.25 and x minus 4.5 squared. Because these here, 9/2 and negative, or 4.5, those are the same number, aren't they? Well, yes. 20.25 and 81 over 4, those are the same answer. As long as it's the same answer, I don't care what form it's in, unless I specify I want it in a certain form, in reduced radical form. So decimal or fraction, whichever one you're more comfortable with using, I would use that. And a lot of the stuff when we start doing completing the square, having it as a fraction, surprisingly enough, will actually be easier to use than some of the stuff with decimals. Because 81 over 4 If I told you to take the square root of 81 over 4, well, the square root of 81 is 9, the square root of 4 is 2. We can do that, yes? If I told you to take the square root of 20.25, or you're trying to take that, that's a little bit harder to do, isn't it? That's why sometimes it's easier to work with fractions, because we can see those perfect squares a little easier than this here. Now, I want you to write these down. Now, I wouldn't use the back page per se, because we're going to do some stuff there. So on completing the square or somewhere, I would have these down, because these here are the main steps for completing the square. Don't use the page that has the two problems at the top. Yeah, you can use the back, you can use anywhere else. I just wouldn't use where the two problems are, because we're going to work those there, so you need space to work them. Not. If some of these steps don't quite make sense, when we go through them here, when we go through it here in a minute, they're going to make more sense. They're going to understand. It'll be the understanding of what we're doing and why we're doing it will make sense as we do this. And when it comes test time, if you want to write these steps on the review sheet, go for it. Because it might be good to have them. Okay. What we're going to do is we're going to use these steps to solve this quadratic by completing the square. And the way we're going to do this is going to follow those 4 steps. So you have 4 main steps. Now the first main step is what? Is a equal to 1? Well, a is talking about the number in front of x squared. Well, is it 1? Yes. That's where this first part is a1 makes this challenging. And we'll talk about it tomorrow, because there are cases where a is not going to be 1. If it's not, make it so. We're going to have to make it 1. But it's 1, so that's fine. So we move on to step 2. Get the constant terms away from the variables and leave 2 spaces. Well, our variables are these here, x squared and x, yes? Because what we're wanting to do here is we're wanting to get to a point, and what we're doing with this step is get to a point where I have a set of parentheses squared, yes? Well, will 7 be a number that's multiplied by itself, or kind of, it doesn't work for this here. This is the perfect square trinomial, because 7 isn't the number. So what we're going to do is we're going to move it to the other side. We're going to get rid of it. Not really, but I want to move it to the other side. And I can do that by subtracting 7. Because these here will cancel, leaving me x squared minus 10x. And I said leave 2 blanks. That's what I mean. Because again, we have a method for finding the value of c. That would go in there. That would make that into a perfect square trinomial that I can rewrite as a set of parentheses squared. That's the whole purpose of what we just did with finding the value of c. Because if I can find that value of c, then this here I can rewrite as a set of parentheses squared. That's the goal. Because if I can do that, we can write it as a set of parentheses squared. But we do have a method for finding that value of c, don't we? And I would write it off to the side. I wouldn't write it underneath because we'll be doing work. So off to the side. We're going to find that value of c. I was going to go here, and well, c is what? B over 2 squared. So what's our value of b for this equation? Almost, it's negative 10. We have to take the sign with it. Now what's negative 10 over 2? Negative 10 over 2 is negative 5. And negative 5 squared is 25. So 10x squared, or x squared minus 10x plus 25 is a perfect square trinomial. We made it into one, which will factor to x minus 5. Kind of like how we worked in the last set of examples, finding the value of c and working it and making it into a perfect square trinomial. We found the perfect square trinomial. Yep. We can make it into a perfect square trinomial because we didn't want the 7. It didn't work in making it into a perfect square trinomial. So we move it away. We move all the constant terms to the other side. Because most likely they're not going to give us a perfect square trinomial, so we move them away. Now if I add something to one side, I have to add it to the other. So negative 7 plus 25 is, what is that, 18. Because we can combine those terms. Any questions on this here? Any questions on anything we've done so far? So we finished steps 1 through 3. And we've almost finished step 4. We found the perfect square trinomial. Now we just need to solve we have a set of parentheses squared. So that means I can use the square root method. So I can square root both sides because the square root and the square will cancel, leaving us with x minus 5 is equal to plus or minus 3 squared root of 2. And the graphing calculator will give you a decimal, so I would use the yellow calculator as the TI-30XS, especially on the test, to simplify the square root of 18. To simplify the square root of 18. Any questions on any of this here? Any questions on anything we've done so far? Is the variable by itself? We have x minus 5, yes? So what I need to do is I need to add 5 to both sides. There's negative 5 plus 5 will cancel, and we get x is equal to 5 plus or minus 3 square root of 2. Now, is 5 and 3 square root of 2, are they like terms? Well, 3 square root of 2 is 3 times whatever the square root of 2 is, which is 1 point, some massively long decimal, yes? So would adding them together, can I actually add them together? No, they're not like terms. There's no way that I can add or subtract this. So that's our answer. Anytime we end up with a square root on one side, or the other, so like this here, we leave it as this because there's no way to really add or subtract these together. Let's start that back. As we can tell with this here, well, 3 squared of 2 is not going to be a nice number. So graphing, this wouldn't work. That's not a whole number. That doesn't work for graphing. Have y'all seen these factors before? 5 plus this 3 squared of 2 or 5 minus 3 squared of 2? No. Graphing doesn't work. Any of the other methods that we would have had don't really work for this here because of the solution types that it is. But this one will work. Completing the square, this method that we used, will work for any quadratic that we come across. It works every single time. Any questions on this here? We're going to look at one more. We're going to look at one more today. This will be the last problem we look at. Now, when we look at this here, is the value of A equal to 1? Yes, okay, so we're good there. So that's step 1. A is 1, so we're good. We can move on to step 2. Get the constant terms away from the variables. So these are our variables. We need to move the 5. And we can move it by doing what? We can subtract 5 from both sides, because positive 5 minus 5 is 0. And we get x squared minus 18x plus blank equals negative 5 plus blank. So we want to leave 2 spaces, because again, once we find the value of c, we're going to plug it back into those 2 spots. And that finishes step 2. Any questions on step 1 or 2? Anything we've done so far? Okay. Step number 3, find the value of c and plug it in. Well, c is equal to b over 2 squared. What's the value of b for this here? Negative 18. Well, negative 18 divided by 2 is? And negative 9 squared is 81, yes? So we can plug 81 in both of the spots. Now that wraps up step 3. So we go with steps 1 through 3 that we're doing, yes? So step number 4, find the perfect square trinomial. Really rewrite this as a set of parentheses squared. We'll have x. What's going to go inside the parentheses is minus 9. We'd have x minus 9 squared equals. I'll tell you that negative 5 plus 81 is 76, because we could plug that in a calculator and it will tell us that. And now we need to solve, or really solve by the square root method. And what can we do? We can square root both sides, because if we square root both sides, the square root and square will cancel, leaving us with x minus 9 equals. Now the square root of 76, well, we'll have plus or minus. Getting ahead of myself. Well, the square root of 76, if we type it in, does work out to be 2 squared of 19, because 4 times 19 is 76. And last but not least, what do we need to do? Add 9 to both sides. And that gives us x is equal to 9 plus or minus 2 square root of 19. And that's it. That's all we have to do to solve this here. So why this is helpful? Well, it helps us to be able to solve quadratics that graphing and factoring and the square root method aren't really good at. Because we can get to the square root method, but it's involves some steps. Because here, we wouldn't have been able to use the square root method until we were able to add 81 to both sides. Once we got that, then we could use it. So we had to manipulate it to get this here. Now the equation that was left out, the x squared minus 18x plus 64 is equal to 100. This here, and there's some like it here, are already set up for it. Because this here works out to be 8 minus x squared. It's already a perfect square trinomial. But we can still use the steps that we did, these steps, to solve this, and we'd end up getting here. We'd end up getting back here. But that is all we're doing for today.